live. And we are live. Welcome for this live stream. This is going to be a workshop for the Reactive Network. So we are going to prepare you for the upcoming hackathon that is coming on September 9th, and that is going to run 8 weeks. And we're going to have $50,000 in prize. So this is a really great opportunity for blockchain developer and on the Reactive Network. Basically, this is based on the EVM technology. So if you already know how to deploy smart contract on Ethereum, you have 99% of the knowledge that you need. And for the 1% that you are missing, today we are going to have the developer relation DevRel of the Reactive Network, Ivan, who is going to give us an exclusive workshop. So welcome, Ivan.
Thank you, Julian. Hey guys, very happy to be here.
Awesome. So first of all, so today you're gonna give us a coding tutorial, but before that, I have a couple of questions about the Reactive Network. So first of all, can you give us a broad overview of the Reactive Network?
Yeah, sure. So Reactive Network is an if this then that on-chain solution for EVM blockchains. So whenever you want to do some on-chain action based on the event on some other smart contract, you need Reactive Network. So the way it works, it tracks the events on the smart contracts that you specify. Then it applies some logic that you describe in a reactive smart contract, which is basically a Solidity smart contract on a reactive network, which is EVM. And then it sends a callback, sends a transaction back to the contract of interest. And the simplest example of that might be, for instance, a stop order on a DEX. So you monitoring price changes on a DEX, like the sync event, if we're talking about, for instance, Uniswap version 2, then the reactive smart contract sees this event and checks the conditions that you specify, and then it executes the predefined trade. So let's say if the exchange rate falls below the threshold that you specify or reaches the threshold that you specify, then it executes the trade on your behalf. So that's a super basic use case, but that illustrates very well what it does, because like it tracks the events and then it does the specified post actions. And that might be done within one chain or cross-chain. That's the question of your choice.
Okay, so basically it can replace a backend. Before the Reactive Network, people would do some backend to do this, but it's like very customized and not easy to do. And now we can do this instead with a smart contract, so which is more simple, but also more reliable, because now we have a whole network that does it for us. So, because I get it. And so you mentioned one use case for Uniswap. Do you have a couple of other use cases?
Yes, we have a bunch of them, and also we are looking for more use cases. This is one of the reasons why we are running the hackathon, because obviously, like our team, it can see less than our team plus all the hackathon participants. So we hope for the guys to come up with some creative stuff and share their ideas. But the stuff that we've already come up with is like, let me give a few more examples. One example might be a cross-chain oracle. Let's say you have some new chain and you want to migrate some popular and reliable oracles to this chain, but obviously it's pretty expensive to partner with them or to deploy all this infrastructure yourself. So you can do the following. You can choose one or several oracles, reliable ones, popular ones on the existing chains, for instance, Ethereum, and you can then create a reactive smart contract that grabs the data from those oracles, like whenever there's an update, it sees the update event, and then it sends this data to your oracle that you deploy on your chain on like or the chain that you're interested in, the new chain that does have all the infrastructure there. And it's decentralized, so it has, as a result, the same data as the origin oracles on Ethereum, but also it's simple and much cheaper than building a new oracle from scratch on this chain. This is a cross-chain example. Another example that I like a lot is this one-step swap. Technically, it's pretty simple, like from the reactive smart contract standpoint, it's pretty simple and pretty similar to the stop order. It works as follows. And what it does, it reduces the number of user-signed transactions for a swap, for instance, or for some liquidity providing, or for basically any other action that you do in DeFi. Because like in DeFi, to send some tokens, to get some tokens from a smart contract, you first need to approve them. So what you do, you approve them with the first transaction, and then you do the actual action, let's say a swap, in the second transaction. And it's a bit of a mess, especially for the new users, because they come into crypto and they don't know about all the stuff. They just do what the interface tells them to do, and they might be confused. And like, it's not obvious why you need to do two actions right away just to do one logical actions to swap your tokens. So we discovered that Reactive might be useful for that purpose as well. And here's what it does. You deploy a Reactive smart contract that monitors approve events, and then you approve tokens not to the DEX of your interest, but to the Reactive callback smart contract that you deploy also yourself. And by yourself, I mean you might build this system for your clients, for your own DEX clients, and in that case, they won't even need to know anything about Reactive, or you might deploy the system for yourself. So you approve tokens for the callback smart contract on the chain where you're swapping your tokens. Then the Reactive smart contract sees this action and triggers the swap transaction on the DEX of interest. So from the user standpoint, the user just needs to sign one approved transaction, and then the second transaction, which is swap, is handled automatically by Reactive, which improves the user's experience a lot. And so this is one of the use cases that we had for our bounty program, and actually one of our bounty participants implemented this use case. And yeah, I believe we have some more. For instance, we can do cross-chain voting automation. So let's say you have users that might want to vote in your DAO or in like some other thing, and they want like you have users on different chains, let's say Ethereum and Polygon, and you want to collect voices from all the chains, and then you want to have them all in one place or in two chains synchronized, and then you want to take the resultant actions such as new tokens issued or some other stuff. So you can do this using Reactive too, because Reactive can collect the votes from all the chains and then put them to all the chains so that on every chain, the result is the same and the result is synchronized. And whenever the voting threshold is reached, the voting decision is executed.
Okay, so very interesting. We have a couple of questions in the chat, so I will forward this question to you in a moment. But just before, I have one last question from me. So when is mainnet for Reactive Network?
Yeah, so with mainnet, we're aiming for the end of this year. And before that, we're already on the testnet. So actually, you can try it right now, but the best moment to try it will be next Monday when we start our hackathon.
Okay, so it's very soon. So we have a couple of questions in the chat. Someone asked if that means we can use React in smart contracts. I can answer this one. No. The name is Reactive Network, but you cannot use React. Then another question is, so is Reactive Network a chain that run oracles?
No, not really. It's a general EVM chain. and it can run whatever you deploy on it. So you can deploy an Oracle there, or like basically what I've described, it's not, so to say, an Oracle on the reactive chain, because there's not much sense in doing that, but that's a reactive contract that synchronizes Oracle on one chain, let's say Polygon, with the Oracle on the other chain, let's say Ethereum.
Okay, so
But you,
yeah, sorry, go ahead. Yeah.
yeah, thank you. So yeah, basically you can implement whatever Solidity logic you want. It's not just oracles, it's general Solidity and general EVM.
Okay. Next question. Can I develop a contract in Reactive to monitor a custom network, and how you manage the list of network the Reactive lessons for?
Yeah, that's a very good question. Thank you. Basically, I would say no, you will need to contact us and to ask us to add this network. So basically, we're looking for network partners who are interested in deploying Reactive, connecting Reactive to their chains. And it's pretty easy for us to add new networks. But no, you cannot just add this network yourself, at least for now. But that's a good idea. We might want to consider that in the future.
Okay, and next question, where can we find more information about Reactive Network? So we're gonna do a tutorial just after the question, but maybe there's like one resource that you recommend, Ivan?
Yeah, so we are trying to make it as transparent and simple as possible. So you can just go to our website and find all the links there. The links would be to our documentation with Getting Started page. And on Getting Started page, you will see also the code examples and all the other stuff. So basically, if you're looking for one point of entry, that would be our website, which will lead to our docs, our blog, and all the other stuff. Depends on what type of content you're interested in, like more technical or more business related and all that kind of stuff. And yeah, on the docs, we have all the stuff that you need to understand and to work with Reactive. Yeah, and also like on this, the blog channel, there was a great video explaining how Reactive works. You can check this out, and you can check out our YouTube channel, which also has a link on our website.
Yeah. So I'm going to link the video I've already done, introduction to the Reactive Network. Let me find this. Yeah, so I put the two link in the chat, link to the doc of Reactive and the other video I did. But for today, we're gonna stay focused on this live because Ivan has a great tutorial for us. So yeah, basically we are going to code your first Reactive smart contract and deploy it. So yeah. Yeah, Ivan, it's up to you.
Yep.
Yeah.
Thank you, Julian. So let me share my screen. I'll start with a few schemes which will simplify the further explanation for us, and then I will jump to the code, and then we'll deploy some reactive smart contracts, and we'll run some reactive transactions, and we'll see how it actually works. Okay, so I believe you see my screen now.
Yeah.
So let me make it full screen. Okay. Is it full screen?
Yes, perfect.
Okay. So this is the basic reactive workflow. We have the origin smart contract on the left, the reactive smart contract in the middle, and the destination smart contract on the right. So the origin and the destination smart contract, they might be on different chains, as in this scheme, for instance, Ethereum and Polygon, or they might also be on the same chain. So what happens is some function is triggered on the origin smart contract, and it does something depending on what's happening in that smart contract. For instance, it might be, let's say, a DEX pool, right? And then it emits some event. That event is being caught by the reactive network. And then this event, in case you have deployed a reactive smart contract, I will shorten it to RSC in the future, reactive smart contract, RSC. Whenever a reactive smart contract sees an event on the contract which it is subscribed to, We will talk about subscriptions also, but basically it works in a way that when you deploy a reactive smart contract, you subscribe to particular events on a particular contract on the origin chain, right? And whenever the reactive smart contract sees this event, it reacts. So the React function is being executed. The React function, it might have arbitrary solidity logic in it. So normally it would be some checks of some conditions, because you, for instance, might monitor some trading volumes. You might check some thresholds and do some other stuff. So basically, whatever you do in an Ethereum smart contract, you also can do that in a reactive smart contract. And yeah, then if all the conditions that you specified are met, you can emit a callback. So in reactive network, a callback event, that's a keyword, that's a special type of event. Whenever you emit a callback event, you effectively call a callback transaction on the destination smart contract. So here we emit this callback event, and thus we call a callback function on the destination smart contract. The name of the event is a keyword. The name of the function may be arbitrary. We will see that in the code. And okay.
Sorry, even a quick question. Is it possible for the destination chain and the origin chain to be the same?
Yes, exactly. Like for instance, in the Uniswap stop order example, they might be the same chain and they even might be the same contract.
Okay.
Okay, and so as a result, you call transaction on the destination chain. I mean, the reactive network calls executes this transaction, and you do this post action. Let me share some more complicated examples, like with this one that I've mentioned before. So I believe Uniswap has implemented some kind of this functionality in their version 4 update, right? But with Reactive Network, basically you can do this stop order on top of a version 2, version 3, version 4, and basically any other DEX which is a fork of the Uniswap code or which is not a fork of the Uniswap code. So it works as follows. We can see the your address on the top left, and it only signs one transaction, the first one, which is an approved transaction, and you approve some funds for the callback smart contracts to spend. Then the reactive smart contract sees the sync event on the Uniswap smart contract. And when it sees this event, the React function is triggered and the callback is emitted. And in that case, callback is swapping tokens. And then within a swap, tokens are being swapped and being transferred back to your account. Okay, and with that being said, let me jump to the code examples. So we have all our code examples on our repositories. Let me show it actually how to get to all that stuff. So this is our website here, Reactive Network. You can go here. You will see the hackathon announcement here. You can learn about what it is, and then you will get to the hackathon page and you can see all the stuff here, but I won't be wasting your time on that now. I'm just showing where it is. Currently, we're interested in the docs and getting started page, because on the getting started page, you have all the links to start your journey, which you will need on the 9th of September when we start our hackathon. And okay, so you can see the hackathon information here, and you can see the links to our repositories here. For instance, reactive demos, which I'll be going through right now. And here is our repository. This is our GitHub, Reactive Network. And this is the example that we will be talking about today, only I will jump to my IDE rather than be showing it from this window, right? So I believe now you must be able to see my ID, correct?
So now we just see the the web browser. We don't see the IDE. Have you shared just the browser maybe?
Yeah, probably.
Yeah.
So let me try again. Okay, how about now?
Yeah, no, it's fine. Yeah.
Okay. So this is the code that we will be working with. And first of all, let me show you where you need to go to use it, and then I'll dive into details. So to start, you will need to go to the README in the root folder and do this basic setup.
Sorry, Ivan, I interrupt you quickly. So this code, we can get it from GitHub, right?
Yes, exactly.
Okay.
So yeah, some basic setup here. It doesn't talk a lot about reactive as is. It basically just the general EVM smart contract setup with Foundry. And the reactive specific stuff, it starts here in SRC folder, demos, and we have all the examples right here.
Okay, so Ivan, I just interrupt you quickly. So just to give you some context, we are using a framework called Foundry, which is a very popular framework for smart contract on Ethereum. And so this is all this code. This is a Foundry project with example of reactive smart contract. It's correct. Okay.
Yes, exactly. Also, if you're not familiar with Foundry, you can do the same stuff using Remix. And we have an article on our docs on how to do the same with Remix. But I believe it will be easier for you to do it with Foundry because it does not imply copy pasting. It just implies you running command line commands, right? So let's start with the basic example. And what I want to share today mainly is the basic structure and logic of what is happening here. So as I mentioned earlier on the first scheme, we have normally, not always, an origin smart contract on which we are monitoring events. Then we have the reactive smart contract, which monitors those events and does some checks. And then we have the callback smart contract on which those post actions are done, on which you want to, for instance, to swap tokens or do some other stuff.
Okay, so let me just give you precision for people here. So basic demo reactive contract.sol, so that's the reactive contract on the reactive network. Then the origin smart contract is a basic demo L1 contract.sol. So it's basically the smart contract that is going to emit the first event. And then the last smart contract that we're going to call back on the destination chain is a basic demo L1 callback.sol.
Yep. Thank you. So, and let's start in the chronological order. So first we have this basic demo L1 contract. You can see all the explanations here in the README. So basically I will be explaining the same stuff, but like in more detail. And also you can run all the commands. We'll do that a bit later. So chronologically, we start with the basic demo L1 contract. And in that case, it's super small and simple, just to demonstrate the concepts and not to overwhelm you with details. So what it does, it receives some ether here. As you can see, this receive function payable. It emits the event, and then it sends the funds that were sent to it back to the sender, basically, back to the transaction origin. And we'll see that in action later. And it emits this received event. And this is the very event that we will be actually monitoring using our reactive smart contract. So let's take a look at the reactive smart contract. This one, okay.
Sorry, even a quick question. Like, is there any constraint on the event we emit on the first smart contract, or we can emit any event?
Yeah, we can emit any event, and we can monitor any event this event might be produced by our smart contract or by some external smart contract, such as a Chainlink Oracle or a Uniswap pool or any other stuff.
Okay, thank you.
Okay, and then we monitor those events using reactive smart contract. So the thing about reactive smart contract is it has some stuff already built into it. It's inherited from abstract reactive and from iReactive. And we recommend for you to do the same, to inherit the smart contracts, the reactive smart contracts that you build from those ones. You can see all this setup here. We won't be going into these details today, probably, because
a quick question about the all those contracts you inherit from. So here I see that they are in the same project. Does this mean that you recommend any for anybody who creates reactive smart contract to start with this repo, or do you have a package published on NPM?
I believe we have, but I don't remember exactly. But yeah, basically the workflow that I recommend would be to clone our examples repository or a boilerplate repository and start from there. Because you will see all the examples, you will see the structure of the project, and you will be able just to build the stuff on top of that.
Okay, awesome.
Okay, so let me run you through this reactive smart contract here. So first of all, this is the event that basically corresponds to the event that we will be monitoring. It has the chain ID of the chain that we are monitoring. In that case, in that particular case, it's all on Sepolia. So currently our testnet, it monitors events from Ethereum mainnet, from Polygon, and from Sepolia, and also from Avalanche C chain, right? And it also does the post actions on Sepolia and Avalanche C chain. And yeah, that's it for today. And by the hackathon, it will be a bit more. We will have all those chains listed on the docs. So in that particular basic example, it's just Ethereum Sepolia testnet. So also we specify the contract address in this event, the topic 0, which is basically the signature of the event. So the type of the event that you want to be monitoring, for instance, a sync event on a Uniswap pool. Then it has the 3 topics of the event, which basically are the arguments of this event. Then it has some data and a counter. So for this example, as I have said, we're working with Sepolia, which has this chain ID, some technical stuff such as gas limit, some variables here being declared, and the actual stuff starts happening in our constructor. So the constructor, as you might know, is run when you deploy the smart contract. And here, what happens here? This is the important part, because when you deploy your smart contract, the active smart contract, it subscribes to the events on the system smart contract. So the system smart contract is the one that basically handles all the events. And for your reactive smart contract to see those events, you need to subscribe to them using this subscribe function here. So this is a boilerplate code, so you don't need to invent it, write it. You just need to change it a bit for your particular example. And for the constructor, basically, that's it. It just subscribes to the events that you specify. You specify them here in the arguments of the constructor, which has the address of the system smart contract, which should be in your variables. And we will see it later in the commands that we run in the command line. The contract address to which you subscribe, the type of the event, and the callback address. So the address of the contract, the callback contract to which you want to send transactions later.
Yeah, sorry, Ivan, there's a question in the chat. So can the contract in a reactive extract the field from the dispatch events of the target network, or does it only listen for it?
Sorry, come again, please.
I pasted it in our chat. Can the contract in Reactive extract the field from the dispatch events of the target network, or does it only listen for it?
Extract the fields from the dispatched events on the target network, or turn the listen for it. I'm not sure I understand the question completely. So basically, it listens to the events that are happening in real time, and then it sees all the fields in that event, if that makes sense. But I don't really understand what's meant by extract here.
Yeah,
Maybe...
you just read the field from the event. That's it. Yeah. Okay. Thank you.
Okay, so basically that's the constructor. And then we have the main part, which you will be mainly working with, which is the React function of the reactive smart contract. So a reactive smart contract, it might have any arbitrary functions because it's generally a Solidity smart contract, and you can implement whatever you want there, any Solidity logic. But I would say that it only makes sense to implement some reactive logic there, which means listening to some events on the origin chain and doing some post actions on the destination chain. And in that case, you will need the React function, because this is the very function which is executed when the event of interest happens, right? And it has the standard set of parameters, which is chain ID of the chain where the event happens, the address of the contract on which it happens, the topics on the event, then some call data, and then some additional stuff
Okay,
here.
I have a question. So no matter how many topic, we always will have the same number of argument, 0, 1, 2, 3.
Yep, because I believe that's the number of topics which can be indexed, and all the other, I believe they go in call data, if I remember correctly.
Okay, and why do we need the VM only modifier?
Yeah, that's a good question, and I'll go to that a bit later because that's a bit advanced stuff.
Yeah, no
Building,
problem.
yeah, but yeah, that's a very good question. Thank you. Okay, so and what happens here is basically, first of all, you emit just a normal EVM event within a reactive network for the stuff to be logged and accounted for later. And that's the actual logic of the function. And what happens here is it checks whether the transfer is bigger than 0.1 Ether. And if it is, then it constructs the callback, which is calling the callback function on our destination smart contract. And then it executes this callback by emitting the corresponding event. I remind you guys that a callback event from capital C is the keyword in reactive smart contract. So whenever you type this, emit callback, you effectively execute the callback on the destination chain. And in that case, this callback, it's here in this payload, right? And this payload is calling a callback function with this 0 address passed as an argument. Okay, and also we have subscribe and unsubscribe functions here. So as I have said earlier, to listen to events on the reactive network, I mean on the origin network, you need to subscribe to the system contract, and it is done in the constructor, but also you can do it later using those functions here.
Sorry, Ivan, a quick question. Do you need a Solidity file for each event you are listening for, or is there just one React function per sol file?
Do you need a Solidity file for each event you're listening for? No, it's just one React function per sol file. Let me to demonstrate this. No, I won't be able to show you the code right now because that's not the code of one of our examples, but that's the code of our bounty participants. But yeah, you can actually listen to different events in one React function. So you can listen to different events on different contracts. And here it might be not just if, but if topic 0 is this, then you do this. If topic 0 is different, you do that. So for each different event, you can do different stuff. Yeah, no, basically I have it here. Yep.
Okay, so we can identify the name of the event based on one of the topic. Maybe it's like topic 1 is the name of the event. So I don't remember exactly.
Topic 0 is
Yeah, okay. The name of the event. Okay.
And it's not only the name, it's the signature of the event. So it's constructed based on the name of the event and the types of the arguments in the event.
Okay,
so yeah,
thank you.
effectively, yeah, the type of the event. And let me show you an example of this to answer your question here. Okay. In our Uniswap example, yeah, you can see that it listens to two different contracts. In case of a stop order happening, it does this. And in case of a sync event happening, it does that. So yeah, within one React function, you process all the events that you want to listen to, no matter how complicated the logic is. It's all handled by one reactive smart contract in this very function. Okay, so we've gone through the second smart contract, the most complicated one of the three. So there is the origin, the reactive, and the destination. And now let's go to the destination smart contract, which is also a callback smart contract here. And in our case, it's also super simple, just for us to demonstrate all the concepts. So as you can see, it's also inherited from the abstract callback, which we have here in our setup, right? So it has some of the necessary stuff built in, and I will talk about this necessary stuff a bit later. But what it does here in this particular example, it just has some events constructor and the callback function, which is being called when we are triggered by the event of interest on the origin contract. Yeah, also this callback name, it's not necessary. It can be any other name, like for instance, swap function can be here or any other stuff. And in this particular example, this function doesn't do anything except for emit the event for us to be able to see it on the destination chain. But yeah, obviously it can do any logic you want, like a swap or any other stuff, which you can see in other examples, for instance, this Uniswap version 2 example here. But yeah, I don't think we have the time today to take a look at the complicated examples, because I think it makes more sense for us to just run this particular setup to see how it works in a super simple way. Okay, so we have those three smart contracts. And now let's actually run the stuff to make sure that I'm not making stuff up and it actually works. So yeah, I have already set up my repository with Foundry.
Sorry, Ivan, there was a question about the callback. What if the callback reverts?
Yeah, if the callback reverts, I would say it reverts. So you can additionally, you can implement the functionality of checking whether the callback was successful. So this is, I believe this is, yeah, also implemented in our Uniswap version 2 example. In a sense, it doesn't process the reverts, but it processes some other stuff. So you can implement this callback with a specific event, right? Let's say with event callback successful, right? And if it reverts, then you don't emit this callback successful event. And the reactive sees that event was not emitted and can do stuff based on that. Or you can process like check the conditions. And if those conditions are not met in the callback function, then you emit other event like conditions not met, and reactive sees that condition not met event and does something else. But yeah, that is a very good question. And I don't think we have working examples on that. I will take a look into that. And yeah, you basically, you have some tools to work with that. But the answer won't be super simple because yeah, handling reverts is not a simple topic, right?
Yes. Thank you.
Okay. So let's go to actually deploying stuff here. So first of all, you can read all the stuff here, which explains basically the same stuff that I've just talked about. And let's go straight to the practical part. So to do the practical part, you need to have some stuff in your environment variables, which is Sepole RPC for you to call smart contract functions and send ETH on Sepole using Foundry. Also a Sepole private key, which you can take from your MetaMask, but like be careful, don't use your main wallet and your main private key for this stuff, because yeah, just not to lose your private key and not to lose the fund. Just use the testing setup and developer setup, right? Then also a reactive RPC, you can find it on our docs as well as some other stuff needed. Reactive private key, which might be the same or different from your Sepole private key. And then a system smart contract address, which is also on our docs. Let me actually show it for everything to be super simple. Docs, you go to getting started page, right? And you go to copy testnet information here. It has everything like chain ID and what we need, the RPC URL, right? And the system contract address. So it's already in my environment variables, but in your case, you will need to put it there to start. And then the first command that we run is the deployment of the first smart contract. The first smart contract that we deploy is a Sepole smart contract, the basic demo L1, the one that we've already discussed. Let me show you again. It just receives some ETH and emits a received event. And yeah, so what this command does, it forge creates, which basically just a deployment of the contract with Sepole RPC URL with our Sepole private key. This very contract here, let's run it. Yeah, make sure that you have enough Sepole ETH on the address that you're using for this deployment, the address for which you have this private key here. Okay.
Even I stop you quickly. If we want to deploy our own smart contract, we can just copy and paste this command here and just change the path to our smart contract, or do we need to create something else?
Yes, if you want to deploy your own smart contract, you just need to like change this stuff here. But yeah, that also depends on what exactly you're doing, because in that case, the constructor of the smart contract does not take any arguments because it's super simple. But in other cases, it will take some arguments as an input. So this command will be more complicated. You can see the examples of that in our other examples.
Okay, so for more complex case, people need to do a script, like normal Foundry script, like any other smart contract.
Yeah. But to run this particular setup and to deploy your own basic smart contract, you just do it exactly as it says here. So the stuff that will be different is those values here, and the command will be the same.
Okay, thank you.
Okay, so as you can see here, it was deployed, and as you can see here, it tells us to deploy the basic L1 contract and assign the deployed to address from the response to a origin address. I changed it to a origin address for the purpose of demonstration. In the original repository, it's just origin address for you to not be confused with this a. Okay, so deployed to this value here. Now I go to environment variables here. Sorry for Russian language here because I couldn't change it. But anyway, it works the same on all the languages. And I put this origin address here and I save it. Okay. Now, the second step here would be to deploy our callback smart contract, to which we want to send resulting transactions here. And this is basically the same command just for a different smart contract.
So to deploy on the testnet of the reactive network, we need which testnet token?
Yeah, currently we're deploying on Sepolia testnet. So for this, we just need Sepolia ETH.
Yeah,
But
sure.
the third step will be deploying the reactive smart contract on the reactive network. And for that, you will need native React token. And I'll show how to get this as well. Just in 30 seconds, I believe. So yeah, this stuff is deployed here. And as you can see, it tells us to assign it to the callback contract address, which will be used in the next command. So let's go to our environment variables, to callback address here, and press OK, right? And now we can go to Sepolia, actually, and take a look at what we've done, right? We can take this origin address here and take a look at this smart contract on Sepolia scan. You can see that there is a new contract which is created 3 minutes ago by me. And also we can take this callback smart contract here and take a look at it also on Sepolia scan and see another smart contract which was deployed 1 minute ago. And now, like there's a uncomfortable thing with Windows for our changes of environment variables to be applied. We need to reboot the terminal here. So on Ubuntu or on Mac, you won't need to do that, but on Windows, you need to just close and open it. So that's what I'll do, because we've just saved a callback address in environment variables and an origin address. So we need to reboot the terminal by closing and opening our IDE in my case. Okay, now
the joy of working with Windows.
Yeah. Okay, and now we are prepared to run the third command. But yeah, as you very correctly noted, we will need to have some testnet ether for that. I mean, React for that. And let me show you how to get it. Let's go here to our docs. So we have the information on the Copley testnet on how to get Copley testnet React. We also have it on Getting Started page so that you will always see it. And I won't go through all of this stuff here because basically there are two ways to do that and you can read about that. But the first and the simple way is to send some Sepolia ether to our faucet on Sepolia. So how it works, you send Sepolia ETH to our Sepolia address, and then you issued React on Reactive Network. So yeah, let me go to my Sepolia wallet here. I have some Sepolia, and I will just simply send it to this address here. For instance, Sepolia. Yeah, but for you to be able to see it, we will need to check the balance of my address, and that's what we'll do after that. Okay, so we have this transaction pending here. So let me check the balance here. Yeah, you can see that I have this balance here, and we'll check it because I've already had some reactive tokens, but it will change a bit in a few minutes when the faucet works. Yeah, let me see whether the transaction was, yep, the transaction was confirmed. So we are getting additional React tokens shortly. Yeah, let me check.
There's a question in the chat. So Reactive Network is its own chain. Is that correct? Someone is asking this.
Yep. It's on chain, and first of all, the reactive network itself is a separate EVM network, and then it works with other networks, and it brings data from one chain to another. So it's like, as I have said in the beginning, yeah, it's an on-chain if this then that. Yeah, and as you can see, this 5 here, my balance just changed because I interacted with a faucet in the way that I recommended. So that's how to get the testnet React. And now that we have this testnet React, we can execute this command here to deploy our first reactive contract. So what it does the same thing as it did on Sepolia, basically deploys a smart contract. It has a reactive RPC here. It has my reactive private key here. It has the name of the contract that we're deploying. And then it gives the constructor some of the arguments. Those arguments being a system smart contract address that we've discussed earlier that we can get on our docs and put in our environment variables. It has the origin contract address, the callback contract address, and also it has this hard-coded topic 0 here, which is a topic 0 for our received event here. So this is this predefined number for this particular example, but in your case, it will be a different number, which you can find out by compiling your contracts.
Ivan, we have a question. What is the reactive RPC URL?
Yep, you can find it right here on our docs on Copley testnet page. This is the RPC URL. Basically, this is the URL of the node using which you will be interacting with the reactive network.
Thank you.
Yep, and now we can see the reactive smart contract, and the same way we took a look at the sorry, Zoom is messing with me. The same way we saw our origin and destination smart contracts on Sepolia scan, we will see our reactive smart contract on our React scan. So this is our website, this is our docs, and here you can see reactive scan. And here you can see your address. In my case, it's this one. And yeah, it doesn't have anything addition because I haven't run this command yet, obviously. So yeah, let's run this stuff here, and we'll see a new reactive transaction. So now we are deploying our first reactive smart contract, and we will see it on React scan, and then we'll test how it works. Okay?
Yeah.
So
someone is asking, where can we get or generate the hard-coded topic 0 you have?
Yep. So first of all, you can find it in your compile artifacts, but then it's even easier to find it using Etherscan. I will show it in a few minutes after we generate the first event. We will see it there. So let me refresh the page, and you can see the first transaction. Yeah, don't be scared of all these failed here's, because it was my mistake. I deployed the incorrect smart contract. So yeah, this is our transaction of us deploying the reactive smart contract. It has some stuff here. Also, we're working on adding smart contract verification capability, but yeah, obviously it's pretty early stage, so just raw data here for now. But the good thing is that our contract has been successfully deployed. Okay, and now let's go to the fourth step in our setup, which is send some ether to the origin smart contract. I remind you that the origin smart contract, what it does, it receives some ether, emits an event, and then sends this ether back. So it's okay.
So basically, this is the critical moment, right? If it works, it works now, or if it doesn't work, we will see it now, right?
Yep. So you can see a drop of sweat right here.
Yeah. All right. Wow. I'm very, very stressed. Is it going to work?
Okay, let's go. Yeah, so what we're doing here, cast send, origin address, RPC URL private key, you know about that. And this is the value of the transaction that we are producing. So it's not even a function call, it's just us sending some Sepole ETH to our origin smart contract. Now let's go to our origin smart contract here, refresh. No, Sepole scan doesn't see it yet, because it just works with some of delay, but I believe it's not big. Yeah, you can see it right here. 17 seconds ago, we produced an event. And here's the answer to the question that we've discussed. This is the received event, right? And this is the topic 0. You can find it here. So in case you need topic 0, you can just take a look at the event of interest on Sepole scan or Etherscan or whatever scan you need, and it will give you this topic 0. Or alternatively, you can find it using your compile commands, and yeah, that's also pretty simple, but I won't be covering that today. So you can take this topic 0 from here. Now let's take a look here. So yep, not yet. And let's take a look here as well. So we can see a successful transaction on our contract here. This is the reactive transaction. And this is an interesting part. So you can see what it was monitoring. It was triggered by this origin transaction here. So it goes to Sepole Ether. And this is the transaction on our origin. This address goes like, yeah, let me see, 1F1, right? And yeah, this is the 1F1 contract here. And this is the transaction that triggered our event, right? And this is the transaction produced by Reactive here. And it's successful. So now we can refresh this page here and take a look at internal transactions here. Okay, here we go. This is the transaction that we were talking about. This is the resulting transaction on the destination chain. So we can take a look at logs, and you can see this callback received event here. So this means that everything worked. And so basically what happened, let me show you the code again. We sent some Ether to our origin contract. It went here. It got back to our account, but then it also produced a received event. The received event was caught by Reactive smart contract here in React function. And then it caught this event. It saw that we sent more than 0.1 Ether because it was 0.11 Ether. And it called the callback function on the callback contract, this function, and this function emitted this event here. And you can see it here. Note that on Etherscan, it goes to internal transactions, not to transactions. So you won't see it here. You would only see it here because of how it shows the transactions. And yep, basically, this is how it works.
Congrats, it worked.
Thank you. Thank you.
Yeah, I mean, people don't realize, but when you do a tech demo, coding demo live, like it's very stressful. It's very easy to make a mistake. So yeah, you did great, Ivan.
Yeah, thank you. I'm pretty confident in our tech and in what our devs have done. But like whenever you run it live, you like, for instance, you might forget to reboot your terminal, or you forget to update one variable and it doesn't work and you don't know why. So yeah, I'm happy that it went.
Yeah, very good. And so I guess next maybe we can answer a few more questions if people have them. So for example, there was a question. Can you use the reactive network instead of a bridge to transfer tokens across chains?
No, you actually cannot use it instead of a bridge to transfer tokens across chains, but it might be pretty useful if you're building your own bridge. because you can monitor the event of tokens being received on one end, and then you can trigger the tokens being issued on the other end.
Okay, very good. Another question we had is how is the infrastructure of the reactive network? Is it permissionless, and can anyone set up a node and run it?
Yep, that is the plan for the future. So on mainnet, this will be the case. We will show all the, we will provide all the node code to the community, and everyone will be able to run a node. But now currently on the testnet, it's just us running those nodes. So yeah, it will be the case a bit later. But yeah, I believe even before the mainnet, even on the testnet, we might go for open node access.
Okay, thank you. Next question, so more related to our tutorial. So you use cast and made a transaction from the origin contract and not from the reactive contract, but the event of the origin is emitted by the reactive network.
No, not really. So the first step, the event being emitted, it happens on the usual support layer. So the first step can be done without the reactive contract, and let's take a look at it here on this support layer. So we just send, so this is our contract here. This is the same contract here. This is a usual Ethereum smart contract. It doesn't know anything about reactive smart contract. It just catches some ether and emits some event. So it might be even not a contract created and deployed by you. It might be a third-party contract, for instance, a Uniswap pool or a lending pool or whatever you need. So, and you can see this event here also here in transaction, in logs, you can see this received event being emitted. Basically, it's a usual Ethereum Sepolia event. It's not a reactive event.
Okay, thank you. So next, if we don't have more tech demo, then maybe we can talk a bit about the hackathon, so how it's going to work.
Yep, it makes perfect sense. So with the hackathon, we will be releasing all the official details this Monday with the track descriptions, with the judging criteria, and all the other stuff. But basically, let me share the general information with you today, and I believe it won't change a lot. It will just has more details. So the prize pool is 50,000. And 15,000 of those 50 will be given like at the end of the hackathon based on the winners. And then 35,000 will be assigned as grants to those teams who produce the most interesting projects. And the tracks will be as follows. So first of all, we will have an open track where all the teams will have the possibility to create whatever they want using reactive. We will just have some criteria limiting this to applications that actually make sense, that actually are reactive specific, because it makes sense to describe what we are looking for, to showcase the capabilities of reactive, not just to create some cool dep, right? So an open track for everyone to be as creative as they want. Also, we will have a no-code track, which actually might be even more creative, because in that case, we will take applications even without the code, just of the ideas for those community members who are not very familiar with Solidity and with smart contract development, but who understand the basic principles and the business side of things, and who know the DeFi space well, who might have some great ideas of how to apply reactive. So they will obviously need to describe that in detail, and that would also need to have a technical sense, but you don't need to implement it, and you don't need to run it in this no-code track.
Okay,
also,
oh, sorry, go ahead.
Yeah, also we will have a DEX track, which will be anything you create but in the context of DEXs, because we have a DEX partner that will be announced that also joined our prize pool, which we are very happy about. And also we will have a deployer track where you can create a reactive smart contract deployer in your browser that will allow all the users to deploy some smart contract templates. And yeah, I think to make it make sense, I will go in a bit more detail, but I won't do that today. You will just see this track on Monday, and that will also be pretty fun because that implies not only creating a reactive smart contract, but also creating some interface and some simple reactive smart contract templates that anyone will be able to deploy on their own.
Okay, so it's very interesting because there are many different tracks, so everybody can choose what fits them the most. And don't forget that there is $50,000 in prize, so that's pretty generous. And so if you already are a blockchain developer and you know how to create blockchain application, especially Solidity smart contract, then you're gonna do fine on the Reactive Network. Just a few tweaks, but this is what we mentioned, what we covered in this live stream. So so you should be well prepared now for the hackathon. So go register for the hackathon. I put the link in the chat. It was a Reactive Network, reactive.network/hackathon. And yeah, so Ivan, do you want to add anything else?
I believe I would just want to reiterate on the fact that the hackathon, it goes for 8 weeks. So even though it starts on Monday, you have plenty of time to decide to participate in it. And you have the time also to share the information about the hackathon with your developer friends, as well as non-developer friends, since we have a no-code track. So yeah, please feel free to join it. Please share the information because it will be fun. We will try to make it as interesting and entertaining as possible for you, as well as like the prize pool is also there for you. So yeah, I believe it's not only it can bring not only money to you, but also some good experience. Because like, for instance, if you are a beginner Solidity developer, you will also have a project on your resume, as well as a chance to win the prizes. And if you're not a developer, you still can participate. So yeah, please join our hackathon, our community, and feel free to ask all the questions that you have in our chat. We try to be as responsive as possible. And yeah, the other thing I wanted to say is, Julian, thank you very much. It's a pleasure to work with you. I like the video that you produced for Reactive a lot about our like setup. It explains the concept very well. I don't know whether we've done a better job today than you've done then. So yeah, thank you very much for the video, and thank you very much for inviting me today to share the technical details about Reactive.
Thank you very much, Ivan. That was very interesting for the audience here today. So yeah, good luck for the hackathon, everybody. And I will see you guys next week. All right.